Right, good morning. First of all, thank you everyone for getting up so early. Appreciate it. I know some of you were out quite late last night, so it's nice to see everyone here. All right, the title, as you see, is Cloud Computing and Software-Defined Networks, but let me lay some groundwork. What this is really about is network transformation. I'm going to be speaking about how cloud services and cloud computing is really changing the nature of how we as a large provider are looking at offering all of our services and managing our networks. All right. The other thing I want to bring to mention is there will be no mention of optics in this talk. All right, so this right now, the preamble will be the only mention of optics. I'm going to be talking about services and things that ride on top, but what you need to keep in mind, particularly if you're working in the optical space, is that everything I talk about is riding over some network, both within the data centers and between the data centers and between the data centers and the customers that are going to use these services. So under all of this are the optical networks, the switching networks, and so maybe you can glean some ideas from what I talk about as to what may have to take place at the lower layers of the network to improve efficiency, improve performance. All right, let me start by talking about cloud as a service, which was the topic I was originally given to speak about. And when we think about cloud computing as a service, there's really two very different consumption models, two ways that the industry thinks about cloud. And they split pretty nicely along the lines of enterprise services and consumer services. All right, for enterprise, it's really more of an outsourcing play. All right, so cloud computing is really all about reducing their startup costs and their overall operating costs to manage back office systems or data center capabilities. So for instance, a enterprise that has to run a back office for CRM or a financial system may find that rather than invest upfront the capital to build out that data center to meet a 12-year or 12-month or 24-month capacity need, and then staffing with IT resources to do that, might find it more attractive financially to outsource that into a cloud computing company. In that case, they don't have to staff up their own experts to run it. They also don't have to lay out the capital up front to build the infrastructure. They're really paying for it as expense dollars, more on demand. So as they need to consume more, they pay more. As they need to consume less, they pay less. So it's a very attractive financial model for enterprises. There's the concept of elasticity or surge handling, and this falls into a realm that the industry calls hybrid cloud computing. So most industries aren't in a position where they're going to hand over their entire back office to a cloud provider. That's not happening. What's happening, first and foremost, is the idea of elasticity or surge. So a process or some activity is run inside the company's data center. But either sporadically or in well-known periods of time, the demand on that application increases. So for instance, in the United States, the Internal Revenue Service, our tax agency at the federal level, has very specific times of the year when they get very, very busy in terms of processing, and then the rest of the time it's fairly quiet. So the idea of surge handling or in cloud computing is the IRS could build out its own infrastructure to handle sort of the average, and then have those same processes running and connected to their data centers, but now out in the public data centers, to handle those surges that revolve around the time of heavy activity with the IRS. Universities are another example. I've spoken to some CIOs of universities in North America, and again, they build out infrastructure to handle all of the back office processes on a university, but they see surges. Surges usually revolve around registration time of classes, right? And so today they have to build out to peak to handle that. Again, if they could build out to an average demand, but run their own processes in the public cloud just for those heavy use times, it can be much more cost effective, right? And below all of that really is most companies aren't about technology and IT. They're selling flowers or shoes or whatever they're doing, and so it doesn't make a lot of sense for them to take a lot of their budget and put it into data centers and IT. It's better for them, if they can, to spend those resources on the things that actually add value to their companies. So that's a perspective from an enterprise. Consumer, when we think of cloud, and I think we're all consumers here, it's very different. And I don't know if you've thought about it this way, maybe you will after I talk through this, but the first and foremost thing that it does is it makes the devices that we buy more valuable. If you think back before broadband networking and cloud, when you bought some sort of consumer electronics, some device, it did what it did, and that was pretty much all it did. And if you wanted something more, you had to wait for the next device to come out, you throw that away. Now almost all applications are tied back to the cloud and back to the network, Many applications don't even run properly. A lot of games don't run properly if you're not connected to the network. So the value now of the device isn't the device alone, but it's the device plus everything that's happening up in the network in the cloud. That's huge. It gives longevity to the devices. It means that in selling a device, it's not just the device, but it's the device plus what that manufacturer brings. And I think Apple's a great example, right? I mean, what would an iPad be if there was no network and cloud behind it? I mean, not much you could do with it, right? It's really the value of their App Store and iTunes and all of that that make that device valuable. The other piece of that, though, is it breaks the tie that used to exist between your device and your personal data. I mean, it wasn't that long ago when if my phone broke or I lost my phone, I lost all my contacts, I lost all my pictures. You know, that doesn't happen anymore. It usually doesn't happen if you're careful, because you can have all that information backed up for you in the cloud, right? So now your data is separated from your device. That gives you flexibility on changing devices without the headache of moving all your information around. It also now lets you publish information from one device and pick it up on another, right? And that's very important. So you might have taken a picture with a digital camera or a smartphone, and now you're sitting at home on your laptop or your tablet, and you want to see that picture. That's not a problem, again, because the cloud provides that. And really, all of those things that I've said are what leads to social networking. And social networking, again, is a very good example of something that, at least in common terminology, you'd think of as being a cloud service. It's sharing your information, your data, your pictures, whatever you have, not just with your devices, but with your 10,000 favorite friends and their devices, right? It's just spreading that all out. All right, so this is sort of the two models that we address. I will say, as a large carrier, Verizon is focused mostly on the enterprise side. You know, there's companies that, Microsoft, Amazon, others that are really focused on consumer and B2C, right? We focus primarily on the enterprise. Again, just, you have to pick, and these are very different models, and as a large carrier, we've focused more on the business side, but that doesn't mean exclusively on the business side. So what is cloud? And it's actually pretty simple, because it's great marketing lingo, but what it really is all about is data centers, connected data centers. So it's shown on this illustration, the box, the rectangle, is showing a data center in a very simplistic way, showing the sorts of technologies and their relationship from a layers point of view that are inside the data center. But what's important to stress is that a data center by itself, sitting on the side of the road someplace, is somewhat useless, right? It has to be connected somehow to the network. So the network becomes a very integral piece of data center to make a cloud. And that network is providing interconnectivity between these data centers, as well as providing the broadband connections to the users of those services in the data center. And that's one of the reasons I think you've seen a number of announcements. Verizon last year purchased Terramark. I think Savvis was purchased, I forget which carrier, there's probably people here, it might have CenturyLink, right? And there's others that have been moving, and mergers and acquisitions. So we're seeing that consolidation. It's recognition that cloud services are very important, so carriers want to have some important aspect related to data services, of course. But the other is that there's that tight synergy coupling between network and data center. So having standalone data center companies and standalone network companies just aren't as efficient as putting those together and optimizing them together, which is why you see this sort of consolidation in the marketplace. All right, as we move into the data center, really you start with a building, right? I mean, you start with simple power, space, and network. Do I have the right networks coming in and connecting? Do I have floor space? Do I have enough power? It takes a lot of power to ramp up all this equipment. Then you start putting in your data center equipment, which is basically storage and compute hardware. Whether it's rack and stack servers or blade servers, you're putting in compute, you're putting in the software to support it. Software is really your fundamental software just to make this thing work, which includes your operational capabilities. It includes your choice of operating systems, right? So if it's Linux, I mean, that's one part of the software that sits here. Many services, most services today require some sort of database structure. So as a foundational piece of infrastructure, you may also have a database system, an SQL or an Oracle, or pick your favorite. It could be an open source. But that really provides your foundation for computing and storage. As you move up above that, something I've labeled very generically is the cloud software infrastructure. But I think more commonly today, think about that as being, for instance, the virtual machine layer, the VM layer, the layer that lets you take those resources below and virtualize them so that they can be applied to specific services or specific customers. The ability to carve up those resources below and allocate them to specific jobs that you can control. Above that, you get into what I call software environment. A lot of the industry refers to that today as orchestration. That's the layer that says, all right, I've carved up my resources and allocate them, but how do I manage that? How do I decide to provide more virtual machines to this job as load increases? Or how do I decide to move the virtual job from this data center, in Virginia to this one in California? That's the orchestration layer. In business services, that's very important because orchestration is the key layer that ties together the private data center with the public data center. So in that model I talked about of surge or elastic computing, what's the layer that allows the enterprise customer to move their job from their internal data center and move some of the processing out to the public? That's the orchestration layer. And above all of that is the things that we usually think about, which is software as a service. A great example of that is something like Salesforce.com, right? I mean, it's basically addressing a back office needs, originally just on the sales channel and CRM, and it's moved up beyond that, but it really is a hosted service, if you will. It's software so that you as a company don't have to bring in-house and the expertise to create a system like that. You can just use it on demand as needed. Because it's cloud, it's available wherever your sales force is, which is usually on the road, right? So they have access to this through the broadband connections, the cloud, and it's a way for you to manage that as if it were your own, but it's in the cloud. So all of these layers independently provide services. So when you talk about a cloud company like Terramark in Verizon, we actually have a whole layering of services. It's not one service. The bottom layer here, of course, is just the access to the cloud and the networking. So I think that's probably the most familiar one to folks in this room in networking. But there's still a very big business in co-location and network access points, which is really at the bottom layer. It's a hoteling service. You're providing power and space and racks and network connectivity for people to put their own equipment in, bring their own networks in, and do what they want to do, but in your facility, so they're not having to build their own buildings, they're not having to work through that issue. They can hire people inside that building to be the hands and feet to change cards if necessary on faulty equipment. For instance, in our Miami NAP, I think about 165 carriers come together into that one data center. So, these are big meet points, and that's a very important service, independent of the other services above it. As you move up, you get into something called hosting, which is where the data center company, the cloud company, if you will, is not providing the application of the service, but providing the computing infrastructure for you to put your own application on it. So here, we have the computers, we have the storage, here's some tools to help you map your application onto our infrastructure, and we host it for you. But you still have to run, Mr. Customer, the application. It's your responsibility. We're just giving you the mechanics to do it. As you move up, you get into things like compute and storage as a service. Those are probably more familiar for those that know Amazon, right? So you have their storage services, and you have their EC2 services, right, for compute. You move up to platform as a service, where really you've taken a whole bunch of capabilities and bundled them up usually for certain verticals to use, working your way up through hybrid cloud computing and really software as a service. Right, this is all great, and this is what I was asked to talk about, but now I'm going to shift gears, all right? So what enabled this to happen, and why is it very important to a company like Verizon, beyond the fact that we now have new services that we can sell, new streams of revenue that tie to our network, but allow us now to leverage these other capabilities? So what we're in a position, really on the cusp, the beginning phase of, is a migration of services into the cloud. Right, I talked about external customers moving services, but let's think broader about network operators and the services we provide. All right, so over on the left-hand side, you have how services are traditionally built in a network. So I've drawn some random network things there. There's some gateways or switches, there's some routers, you see some storage and some other components, there might be a firewall in the picture. Those red stars indicate where service intelligence lies today in a network. For better or worse, it's just historical, services are distributed out across many elements in our network, right? So I have services that sit on top of the gateways, which might be SBCs, for instance, services that sit on the routers and the switches, and if I'm making an end-to-end service, I'm probably requiring some service logic in all of those boxes. So think about the complexity today of adding a new service into a network. It's usually not just one vendor's one box that I have to change. It's really probably making changes on, those might be all different vendors, right? All different types of boxes and technologies. I have to address all of them work through the systems integration issue of what has to change on all of them to make this new service, go through having that done by the vendor, then doing the testing of it to make sure it really works the way we think it's going to work, and rolling it out. It takes a very long time. That's why you don't see a lot of network services rolling out very quickly. It's a very complicated process. So what's changed? Well, the cloud computing infrastructure itself has changed dramatically in the last 3 years. The performance of computing chips, basically traditional x86 infrastructure, which I'm calling here COTS, commercial off-the-shelf hardware. So not special ASICs, but commercial off-the-shelf chips can now process packets in real time at 10 to 20 gigabits per second. Right? And that's just the nature of Moore's Law and where chips have gotten. But that's a new enabler, is that we can do real-time packet processing now in computers. It doesn't have to be on ASICs. There's places in the network where we're dealing with 100 gig links, that of course you're still going to use special purpose hardware. But when you're dealing more with the client side or services side, lower rates, you can start to do that in computers. Hardware and software separation. You know, for years we've been buying services from our vendors that are software, but they come packaged to us on hardware. So, you know, I can't tell you, how many pieces of equipment I've bought from many vendors, many of you in the room here, and it comes sitting on Sun compute hardware, which isn't probably called Sun anymore, but Sun compute hardware, right? Because, the vendor would take their service and put it on the hardware and send it to me. Well, that's pretty inefficient because I don't know, the release of that hardware and its management and the price points all tied to that one service, that one capability I'm buying from that one vendor. With the separation, this horizontal separation, I can decide what compute hardware I want to buy and buy it in volume, maintain it at a common release, operate it in a common fashion very efficiently, and then just be purchasing software to run on it, as opposed to buying these vertical bundles. That's a big change in how we address getting our services. And then lastly, with virtualization, we really improve the efficiency. So I don't have to stand up a dedicated rack to do this network service function and a different rack to do this. If I can virtualize that software, I can get some level of gain and efficiency on shared hardware if in fact those services aren't always competing for the same resources at the same time. So efficiency is created. So the result of that is the green star, where now I can take a lot of distributed service logic and centralize it. Centralize it here doesn't mean geographically, by the way. So it's centralized in the sense that it's in a common operating and hardware environment. I may still choose, for reasons of performance and resiliency, to have this spread over multiple data centers geographically. But from an operational point of view, I've centralized the logic. So if I want to make a service logic change or enhancement, I kind of do it once, and it's much quicker and easier to test and move into service rather than all those points I have to touch. It's global presence. Our IP and optical networks are global. Our data centers are global. So I'm no longer tied to services that are bound to some specific elements that might only reside in North America or in Latin America. I now, if I can put it into the data centers, can make it available very quickly in any region I need to make it available. So this is a big change. And this is a fundamental change. It wouldn't have happened without the concept of cloud and cloud computing, but it's a new way to think about how we do some of our networking services. So what I want to do, spending the last few minutes I have, is give some real examples of this just to ground it. So one, because we're engineers and not marketing people, we call elastic cloud networking. All right, but really what it is, it's a program to look at, can we take IMS, and I don't know if people are familiar with IMS here. That's IP multimedia subsystem, which is what we run, SIP, voice over IP, on our wireless networks. It's sort of the standard coming out of 3GPP. It's the sort of global standard for IP communication services. Looking at moving that into the cloud. All right. Well, why would we do that? Well, the problem statement is, as at least Verizon has built out their LTE IMS network, we've done it in a way that's really optimized to having hundreds of millions of human users. So it's a very large, sort of flat domain, optimized for people with smartphones and tablets. It's great. There's nothing wrong with that. But if I think of new businesses I may want to enter with that network, like machine to machine, those aren't subscribers. My refrigerator and my car don't have billing addresses. And there's lots of those, right? A lot more than there are people. It's a very different model. It's usually very transactional, right? Also, multi-tenancy. If I wanted to spin up a private IMS service for an enterprise customer, I can do that today, but it's very hard to carve that out of the existing network. All these things can be done in the existing network, but it takes a lot of time and it's very complex. So what we're trying to do here is leverage cloud computing, turn this into software that runs in our data centers so that we can build it once and spin up instances as needed for these different applications. And the two examples I gave were machine to machine and sort of the idea of a private IMS for enterprise. The table here just talks about some of our goals. We're not going to hit those goals this year or next year. These are more aspirational goals. But the idea that rather than a deployment cycle of a new service being 1 to 2 years, based on what I described to you of complexity, getting that down to days or weeks, right? Instead of having complex failure of interrelation of these devices in the field, using the tools available to us in data centers, having a more predictive way of understanding when we're running into problems and maybe fixing them before they happen. Instead of having large geographic domains of failures, which we see today, by spinning up multiple instances rather than one big flat instance of a service, if there are problems, I can contain the geography or the scope of that failure. Utilization on the assets will go up greatly because of virtualization. I talked about global, and the net effect of all of this is really driving down the service cost. And we really think it's an order of magnitude drive down. So that's one example, looking at a real-time service like IMS. Another example is software-defined networking. That's a probably overused term, means something different to everyone you ask. But here's a real example, which is, what if I looked at the packets flowing into my network, and I wanted to route them not just on decisions that might be made at the optical level based on mappings to wavelengths and GMPLS, or not at the router level based on OSPF or ISIS shortest path routing. But what if I wanted to do some of the things listed here? I wanted to base my routing on subscriber policy, or through application type by looking at the packet, or based on cache fills around the network, or other states, for instance, radio access network congestion. That changes quite quickly. Typical routing protocols, either at the Ethernet optical layer or at the IP layer, don't account for those sort of things. These are very important attributes that we'd like to put into the network. Very hard to do down in the network layer, the optical layer, the IP, the Ethernet layers. But we could do that now in computing, right? Again, not for 100 gigabit links, but at some level we could take a stream and look at it and apply those sort of routing decisions as opposed to traditional routing. All right, so we do that today. So there's 3 data centers represented there, and one I'm just simply calling generically traffic optimization. So in this example, I'm looking at traffic coming in from the internet, and I say, oh, look, this is a video stream. And then I say, gee, what's the state of my RAN network that my consumers, whoever clicked on that video and wants to watch it, and I can check and say, well, is it coded at a right rate where they're going to get a good quality? And if it is, maybe I dump it into the local cache and it gets streamed out to them. But maybe the video they requested is coming in at 5 megabits per second, and they're stuck in traffic on the 101, and everyone's there on their 4G, and there's only 500 kilobits available at that point in time. So sending them a 5 meg movie is just going to lead to a bad customer experience. So instead, I could divert that traffic into a transrating engine in a data center and have bit rates change down so that you'd actually have a decent viewing experience instead of just a frozen frame. But that has to be made on a real-time decision. It's not IP or optical routing. So we can do that. And actually, we are doing some of this today. The issue, of course, here is that I'm looking at all the packets and software. And that's a bottleneck. And that means that I'm constantly chewing up my cloud computing resources, even on a 1-hour movie, where the next packet and the next packet and the next packet are all pretty similar, right? It's a video stream. So the last thing that we haven't done, so again, this is sort of a future look, is if there are things like, and OpenFlow is just one example here, if there are ways for us to speak to the network devices, to tie together the data center infrastructure with the network infrastructure, not keep it isolated. So in this example, I call it OpenFlow because it is a spec, an open spec, but there's others being worked on as well. The model could be, I look at that stream and I say, wait, this is a movie, and I know how to handle it, but rather than look at every single packet from then on out in that stream, I signal some kind of controller, in this case an OpenFlow controller, and that controller speaks to, I call it a hybrid OpenFlow router, but it could be a packet OTP device, it could be a router. I'm sorry, I mentioned optics there. I said I wouldn't mention optics. It's, and it could some of the resources in that device now have been allocated to be controlled externally. That's why it's called a hybrid device, right? So it can still do its normal function, but I've pulled away some resources that I'm now letting this external controller have rights to. That OpenFlow controller then, in that case, would push down the appropriate routing path, or forwarding table, if you will, to that device, so that stream of video would go to the appropriate place, which is a much more efficient way to do it at the network layer, instead of putting it through that cloud for every packet. So that would be sort of a place to get to. Really nice optimization. We're not there. I don't think the industry's there. But this is a direction to go where you start bringing cloud computing and software-defined networking together, which comes out of data centers, with the network elements themselves. So let me just wrap up in summary. Right? So cloud services for Verizon, and I think for all of our other Tier 1 partners, are a high growth area. So we're all getting into it either organically or through acquisition. You see that in the marketplace. The technology itself has evolved, so it's no longer just doing back office business transactions, but we can support real-time services. I mean, that's the key change in the technology that's occurred over the last few years. This allows for large-scale software-defined networking. All right, that's great. So now I can start doing real-time communication services out of data centers instead of in the network. But I still have some inefficiency, as I just described in my last example. So we'd like to get things like OpenFlow, and I'm calling that out here because that's the one spec I'm aware of that's been out there and is being used by some vendors. I'm sure that'll be an interesting debate over time as this takes off on what's the right protocol. But OpenFlow-enabled routers with the ability to optimize the network traffic between sort of transactional services that run through the data centers and those that really need cut-through services through the optical and switching and routing layers. All right, and this is really revolutionizing how we think about networking. So it's not just, hey, we're buying data centers, we have this new service we offer. All right, that might have been the starting point, but looking inside of it, we said, wait, this can really change how we build and grow our network services in the future. All right, so thank you for your attention.